The Fraunhofer Institute for Solar Energy Systems is the largest solar research institute in Europe. Since 1981, work has been conducted on highly differing tasks dedicated to the use of solar energy. Photovoltaic has now become relevant for many sectors and can be found in every climate zone of the world. More and more manufacturers are attempting to enter the continuously expanding market. Material testing, certification and quality management gain ever more importance. The world's leading solar companies strengthen the positioning of their products by ensuring high quality, convincing certification. Since 2006, the Institute's recently founded Test Lab PV Modules supports photovoltaic manufacturers in questions concerning the development and quality management of their products. It runs the tests a PV module has to pass in order to achieve respective certification. Custom-built applications provide reliable reproducibility and highly precise test results. The Test Lab PV Modules sees itself as a flexible service provider. Special customer wishes and the testing of exceptional designs can of course be implemented with the adaptable testing facilities. For the test procedure, 8 modules are required. They pass through partly differing test procedures. Splitting of the modules optimizes the total testing time. Smallest deviations on single modules can be better compared and referenced after several tests. For the VDE certification of products, 19 tests for thin film modules and 18 for crystalline PV modules are implemented. As a first step, modules are exposed to a defined irradiation dose. Thin film modules additionally pass through an artificial light soaking procedure. In order to maintain electrical safety, isolation tests are carried out in dry and wet conditions. Outdoors, the actual performance of a module depends on many different factors. The flasher determines the module's output power, irrespective of external factors. Each module is placed in a completely dark room and exposed to a specified irradiation. The performance is standardized via the lightning effect of 1000 watts and 25 degrees Celsius cell temperature. The emerging IV curve allows comparison with other modules. Climate tests are carried out in several climate cabinets. The materials with which a PV module is manufactured are tested according to their general resistance to heat, cold and humidity. In order to obtain accelerated aging, testing conditions exceed normal operational conditions. 2 of the 8 modules run through a thermal cycling test. During this procedure, temperature passes through 200 cycles, alternating from -40 to +85 degrees Celsius, causing extreme thermal stress within the module. 2 modules are subjected to the humidity freeze test. 2 further modules must pass the damp heat test. Climatic tests cause maximum stress for the modules. The mechanical load test constitutes another important part of the certification procedure. Here, extreme conditions such as wind, snow and ice loads are simulated. 3 cycles, each of which requires 2 hours, are implemented, in which the module's front and rear are exposed to a static load of 2,400 Pascal. If the module is to be certified to withstand heavy snow and ice loads, its front is loaded with 5,400 Pascal during the last cycle. Since modules also have to survive moderate thunderstorms, a hail test is implemented. The in-house developed hailstone freezing station ensures that hailstones are free of air voids. Each stone is 25 mm in diameter with an exact weight of 7.5 grams. A special compressed air cannon determines the robustness of the module via standardized target spots, such as conductor connections, for example. A hotspot occurs when modules or single cells are partially shaded. the shaded part becomes reverse biased, which leads to heating effects. In the worst case, it may even heat up to temperatures that cause serious damage. For this reason, a hotspot endurance test is run in the climatic cabinet with Solar Simulator. The test determines whether a module can stand the effects of heating that may occur as a consequence of full or partial shading. For safety testing, the VDE conducts a breakage test on a module. General and electrical safety must be ensured even after destruction. In order to estimate the energy yield of a PV plant, it's also necessary to know module yield in cases of low irradiance. As part of testing, the nominal operating cell temperature is also determined. The so-called NOCT enables PV plant designers to estimate module temperatures during real operation conditions. A module's performance depends on its operating temperature. This correlation can be described with the aid of coefficients which allow the calculation of a module's real performance at specific temperatures. Performance measurements are repeated after each test influencing materials. The performance degradation of crystalline modules should not exceed 5% between two measurements and not more than 8% during the full test sequence. At the end of a test series, customers receive a test report as well as measuring protocols for each test. Our partner VDE then certifies the successfully tested product. Our experts for durability analysis and environmental engineering are happy to support you with product developments and carry out testing prior to market launches. In questions concerning non-certification, they adopt an independent advisory function. The Test Lab PV modules is equipped with a large number of additional test facilities for determination of failure modes and causes. By means of special test methods, knowledge of changes in material properties is gained. Electroluminescence measurements, for example, show finest microcracks invisible to the human eye. Our research on material permeability, aging processes and material modifications provides illuminating insights and fresh impetus for further developments. Long-term outdoor exposure under different climatic conditions aids the understanding of the kinetics of natural aging and enables the development of new and more rapid test procedures. As a member of the Fraunhofer Institute for Solar Energy Systems, the Test Lab PV modules adopts a unique position in which science and business are combined. It's an accredited independent certification laboratory and a long-term partner with a research mission.